Okay. 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 Yes, William, let me see. Got your message. Okay. Anybody, you want to record this? This is going to be 90% of this class session is about talking of programming that applies to Thursday. Okay. Okay, I'm going to switch the camera and you'll see the notes happening. There it is. Okay, that cable, that's the mouse wire. Keeps getting in the way. Okay. All right, I should explain about your midterm. Um, let's see if my sound volume is set well. I think it is. Okay. I graded lots and lots of midterms during the vacation week. I'm not done with your section. It's about half, not even quite half done. I'm about 40% done with, you're in section 5, and I'm still working on it. I've sent back a few already, but I'll keep working on it as much as I can. I am going to get these all back to you. I guarantee you, and I guarantee myself, it's a task I got to get done. Okay. Um, I think we should postpone discussing the midterm and working through all the problems until this coming programming test is done with. So let's focus on what we're going to do on Thursday. That's this piece here. That's kind of a useless marker. Okay. Okay, programming tests, and I made some notes about this. This is it. Okay. First, let's pick a time. Um, I'd like to give you the extra hour. Can we do this at the beginning of the regular class period? I know it interferes with, I can never make everybody happy, but this may interfere with some other plans you had. What if we start the test at 1 o'clock, 1 p.m., and that's an extra free hour, and then we'll go to 2 o'clock, and we'll go to 4 o'clock. And 3 hours. Um, I know this is unexpected, but see, the 4 o'clock and later interferes with advising I have to start up. So I have, it's not impossible, but I have issues after 4 p.m. So for me, it works easier. It works better if we start at 1 o'clock. Um, okay, so watch. If you have issues with that, let me know. But for everybody, make your calendar say be ready at 1 o'clock. Be at your computer 1 o'clock or a few minutes before 1 o'clock on Thursday, like 12:59 p.m. Thursday. Okay, everybody got that? Red doesn't show up very well. I'll stick with black. Okay, at that time, I'm going to mail out your test copy, and it will be a description of a program to make. And here's the next topic. You really got to use what has been covered in this class without going outside of it. So I'm discovering that my markers are really dead. I'll throw that away. Okay. So what I mean by that is use 64-bit Intel SSE technology. Okay. There's been a few of you who sent me programs that are written all in 32-bit registers using not SSE. SSE is the group name for XMM registers, but using FPU registers, and it's just nothing that looks like what I've been teaching you all. So to make it a level playing field for everybody, a level curve, you need to make your programs look like the ones that are posted online. No AT&T syntax, no 80-bit floating point registers from FPU, but just the standard stuff that we've done all semester. Got it? Okay, next. Where's my yellow pages? There's some more. Let's talk, this is a big one. Let's talk about reusing software. On a test. Okay, generally I'm in favor of reusing software, and you can do that on a test, and it's not plagiarizing. And here's the background to that, is that there's a culture called FOSS. That's free, open source software. Okay, and the general view is that if a person or a group of persons makes a function, a software module, and they allow the world to use it, then it's open source and it's freely distributed among other programmers. So I encourage that, and on a test you can use, so here it is, test. It's an open note test. Use any software from the web, from the class website, programs you made earlier this semester in your computer, whether you send them to me or not. Programs that have links in Discord, any program that was made before 1 o'clock on next Thursday. Any program made by your classmate. If it was made before 1 p.m., that's our starting time, 1 p.m. on Thursday. Then sure. And you can bring it to your computer and you can use it. So None of that is plagiarism. That's all open source false stuff. So there is one limit though. This is for academic purposes. After the test starts, you cannot email your classmate and say something like, when you're done with your program, can you send me a copy and I can put my name on it and I won't have to do all that programming work. So after 1 o'clock, then don't embarrass the other person saying, give me your program. They won't pass the plagiarism test if two similar programs arrive. After 1 p.m., no more borrowing. Now that's an academic rule. That's not from the world of open source software. I have to make a fair playing world for everybody when the curve is made. So if we all do our own work, everything's fine. Okay. Well, I have some notes here on the side. What should we open source rules? Okay. Let me back up. This applies to Thursday. What is software's let's back up a lot. For whom do you make programs? Program. You're early professionals. You're on the way to a career in software development, and you're in training period while you're in the university, and you make programs for practice. Eventually, you're going to do it for programs for cash, for a salary. But who are you making these programs for? Uh, Tuan, did I not give you permission? Sorry about that. Yeah, here. Okay. Then William, you're okay. Okay, I'll give you. You don't have to answer. I'll tell you the answer. For whom do you make these programs? Like on Thursday, you make it for the teacher. All the classes you take, the program that you're making, whether it's an SQL or Java or something else, it's for the teacher. Okay, and after you graduate, who do you make the programs for? You make them for your team leader. You make programs for your project manager. You make programs for just under the camera. I hope it is. Yeah. Okay. Um, Chief Technology Officer of your corporation where you work. You make it for the CEO of your corporation. You make it for the other company that's going to pay money to get the program that you're developing. So that would be the customer. And you notice who's missing on this list? Out of all this stuff, one person doesn't get to have any programs. It's kind of tell you who. It's for yourself. I'd be very surprised if there's anybody enrolled in this course who says very honestly, I made a program just for myself. I'm not showing it to anybody else. I'm not going to let anybody else use it. It's just for me. Uh, to me, that's probably happened 3 times in a whole lifetime. It's always for somebody else. It's for the classroom. I make programs. It's for my portfolio. I make programs and so. Okay, so What that means is if the program is going to go to all these other people, like you're in a programming team, and the team leader says, I need samples of your work by Friday evening, Friday closing time to know what you're doing. It's for somebody else. So when it's this doesn't happen. When it's for somebody else, you want to make it as nice as possible for that other person. I make this comparison. Your one of your good friends is having a birthday. You're going to get a gift for this person, and you pick a nice gift in some wonderful store, and you wrap it up in pretty paper, and you put nice ribbons around it and a nice card. And the card says, "Wish you this happy birthday," and you make it as nice as possible, and then you give it to the other person. That's what you're supposed to do with software. You're supposed to make it as nice as we can possibly make it, and then you deliver it to this other person on this list, like teachers and program leaders and project managers and the CTO and the customer. They all get it, but you want to make it as nice as possible. And earlier through this semester, I've been calling that the professional program, just to have a one-word title. So because it's not for you, it's for somebody else, you want to make it a professional program. And then I went through all this stuff about professional programs have author contact information, and it has the development platform where it was built, platform IT. It has the program has a name to it. The program has a statement of purpose. The program has some sentence about how much testing was done on it, were any deficiencies found, and its name there. So, and then it's constructed in modular blocks, especially assembly, less so in C++, but construction in, well, to be short, I'll be just in blocks and so on. So that's making it professional. And because your years in the university are training time, you want to make yours approach the level of professionalism. Okay, what about Thursday? No, we're going to dispense with it. You don't have to be professional. You just sort of have to be academic level. So Thursdays test. I do need your contact information. You as author and your email. These things are good to practice at another time, but here we're constrained to 3 hours. Let's You don't have to do it. Okay, so they're dispensed with for test purposes. Now, in C++ and the C, you don't have to follow this block construction. The reason is C++ is readable. You can pick up a C++ program and just read 3 or 4 or 5 consecutive statements, and you sort of know what it's going to do. It's clearly evident. Assembly, you can stare at it for a long time, and I still don't know what it's going to do. So assembly needs block structure. When you say segment text, and then there's a program name here, consumer, the 2 dots. Official name for that is entry point, by the way. Okay. Then you, out of your natural ability, natural instinct, it should be that you think of what action am I going to do next? I'm going to back up my registers. So the block is called backup registers. What am I going to do next? I'm going to welcome the user. Welcome user with info. I want to inform the user at the same time. Okay. So even if you're not programming for a test or you're not programming for any other thing, assembly programming should flow out in these blocks of there's several assembly blocks, several assembly instructions inside of each box here. If this was C++, it's a one-liner. It's a C out kind of statement. In assembly, it'll turn out to be 5 or 6 statements. And then 5 or 6, actually, there's about 16 statements. All right, that's the block structuring. And for assembly, I wouldn't say it's absolutely mandatory in the test, but in practice programs, you really need to practice assembly that way. My personal view is you don't need to comment on every single line. So the block might have five instructions in it. You don't have to comment all those. The reader can just look over here and read the instruction. You don't need that. But we do need, like me, I'm the grader this time. I need to know what the whole block does. Did I ever tell you how I evaluate programs submitted? Before even running it, I look at the assembly function, and mentally, I can't do it physically, but I mentally block out reading source code statements. And I read the heading on this block, read the heading on this block, go to the next one, read the heading on this block, go to the next one, read the heading on that front of that block. And by doing that, I can tell the whole, I can absorb the whole story of what it's doing. I don't need to, and I don't want to read code. That hurts your brain. But I read the story. What's going to happen here? 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 By the time I get to the end, the return statement, I say, this programmer got the right algorithm going here. Without the assembly statements, I could reconstruct the whole program just knowing the sequence of logic from reading those titles on the blocks. Then evaluate it. That's a real good program if I could manage that. Now, it happens all the time. One of these will say output. That's all it is. Just one word, output. I say this person hasn't got it. This is going to fail. And sure enough, there's a sig fault somewhere when I try to run it. The word is so meaningless that it doesn't say anything. So that's how I evaluate your programs. And then I send you feedback about it. But it's a good assembly program if I can read only the block headers, and then I say, I know what this is going to do. Let's go on. What's next on my list? Yeah, this was on the concept test, and it'll be on the final exam concept test. At the early stage, university stage, people think it's a waste of time, but it isn't. That's the levels of the legal ease behind software. From most restrictive and I should put on, it's on the side, is Creative Commons. But Creative Commons sort of on the side because within it, there are 4 different levels. Okay. So this is very restrictive. This is also known as proprietary. Okay. Yeah, whatever it is. Yeah. It has a EULA on it, end user licensing agreement. Okay. This is semi restrictive, and this is very minimal. So this is minimal, and then this is, there are some restrictions. I'll tell them to you right very soon. This is intended for entire applications. Okay. So EULA says you can't do anything with this software because you have no rights to it, you have no ownership. There are no rights conceded to the customer in a EULA agreement. The EULA agreement only specifies rights held by the vendor of the software. Okay, so we don't deal with it. It's just kind of boring. Okay, a GPL reserves 4 rights for the customer. The right to see the source code, the right to run it on as many machines as you want to, the right to modify the source code, and the right to redistribute it, the original or the modified version to anybody you want. There's 4 rights reserved to the customer. 4 rights. There are a small number of responsibilities. There's one responsibility is it cannot remove comments by previous developers. Remove the names and the comments of people who built this. Not remove or the license from those who, you can add your own, that's okay, but it would be a violation of copyright law or licensing law to receive a or download a program that has this licensing and it applies to this one too, and then start removing the names of the previous authors and leave it without comments or explanation. That's all you leave it. Okay. But one of the restriction is here that if a GPL function, just one function, is placed inside of a larger program, the whole program has to be licensed GPL. Entire program becomes GPL, must become GPL license or not, or don't put that function in there. LGPL is different. It says that if you put a function that's licensed with GPL inside of your program, you don't have to do anything with your program. You can make it public domain, you can make it EULA, you can do anything you want with it. GPL says nothing about what the program is that will use it. There's nothing about the using program. Using program. Do we have an example of GPL? Yeah, we do. Example. Is this under the camera? Hope so. It is a big example. IsFloat is an LGPL. That was made by a student about 3 semesters ago. He told me he put the LGPL license on it, and it's been posted in Discord and in various websites around the world for 3 semesters. And because it's LGPL, you take it and you put it in your program and don't modify it. You don't, if you don't make changes to IsFloat, you can use it just as it is without modifying anything inside. It's free software, and that's not plagiarism. That's, I don't take points off for it. Okay. If I don't think we have access to any EULA, but if there were EULAs around here, then you'd be in big trouble. Okay. So when you're using IsFloat, it I thought this was made by Bilal, but I can't be certain of it. The first original copy. You get the copy from some other student. It should have somebody, some programmer's name in there who first built it. Just leave it and go ahead and use it. If you modify it in some way to make it a little bit better, then your responsibility is add your name below the other person's name. Now there's two of you who have worked on this program, and that's okay too. So you should have a copy of IsFloat on your computer. It might show up on Thursday's test, but don't worry. You don't have to put your name in it even. If it says Joe Schmo in there, uh, you don't lose points as if it were plagiarizing. It's actually good programming culture to leave other people's work as it is. The only one that gets you in trouble with this course with me is if you send some other classmates Thursday program as if it were yours. That's a no-no. Let me look at the list. So what do we have to do? Any questions? Okay. So, okay. Never remove other people's comments. A future programmer may want to understand more about the execution of the function itself. And if you took out the comments that explain it, its name or its purpose, you're harming somebody else who will later receive the same function. Okay, how about did I go over that there's three kinds of software? There are library software, application software, and system software. Each one is kind of different, and there's programmers who specialize in each kind. IsFloat is an example of a library function. How do you know a library function when you see it? I don't know if I'll give you a test that you could apply. If you read the source file of IsFloat or anything that claims to be a library function, you read through it, and there's no mention of how it. There's no mention of a program that it belongs to. See, it's not part of what's it's not part of Titan registration system. There's no comments around. The variables are not named for Titan registration system. It's just bland, generic software. The chances are very high that it's a library function. If the function starts naming what dollars and cents, accounts receivable, payroll payable, it's part of some application that belongs to an accountant uh, in the school bid. See, there's a difference. If you can look at it and see that it does nothing, it does something, but it isn't related to anything specific, then it's probably a library function. IsFloat checks to see if a number is a floating number or it's not a floating number. That doesn't belong to a gaming program. It doesn't belong to a word processing program. It's not part of anything. That's a library function. An application is Microsoft Word. That's a full-blown application. It's to enable word processing. That's in this category. And system programming are those functions that are added to the operating system. Okay. There might be another great category, but I don't know it. I know of these three big ones. And library functions, generally speaking, are LGPL. Applications are just GPL. I don't know what these do. Take your pick. I'm not certain. I never even investigated that. Okay, so uh, let me see. Did we cover stuff? Okay. So on this coming test, I need Thursday. Give me this bare minimum. Give me your your contact information. Two things: name and email. You don't even need the C word. It didn't. I can identify you from those two. Um, and block structure in the assembly file. That's it. Block structure in assembly. Yeah. That's not professional level, but it's good enough for full credit on a test. Okay. So when you go to job fair and you're going to talk to those recruiters, your portfolio has full professional software, but we don't have time. Our 3 hours should be spent on doing the programming, not making the ultimate level of acceptability. Okay. Let me see. I'm looking at my handwritten notes to see if there's anything. We're going to talk about arrays in a moment. Um, most more. Okay. This is about the old midterm programming questions. Kind of off the subject. I recommend you get a copy of the answer key for the concept test. I've been told that by a student that he posted it in Discord. Okay, let's see. This is for the job market. Okay. Okay, and I'm trying to isolate it down to things that you'll need to know for Thursday. I got all kinds of stuff here about the job market, but we can do that a day later. And let's see. Don't use obscure assembly like 32-bit stuff and floating point registers other than XMM. Okay, so on the job in software development, it's just I don't know why I've been there for a short time in my life. It seemed like Friday afternoon is the time they have a lot of group meetings. Just after lunch, like 1 p.m. Okay. Your project leader calls the group together and says, we're going to have a group meeting in room 200 at 2 o'clock. Okay, bring your work from since the last group meeting. We're demonstrating, we'll discuss it. Well, what you don't want to do is on the day your team leader calls for a group meeting, you don't want to come empty-handed and say, yeah, I didn't do anything since 10 days ago. 2 weeks ago on Friday when we had a meeting, since then I don't have anything to show for it. My stuff has a sig fault. That's really no. You don't want to show up with something that doesn't fly. So here we go for Thursday of this week. What do you do if it's getting close to the hour when you have to submit it and it's sig fault? Okay. If don't submit a program with sig faults because I can't verify your logic in your software design. I can't confirm anything if it bombs out, crashes in the middle of a run. It just doesn't tell me anything. What you should do is to have a strategy. When you see seg faulting, there's usually some output and there's some dialogue that's happened. There's been a welcome message, there's been a prompt, there's been an input, there's been some more calculations and some output, and then it says seg fault here. Okay, so you have to intelligently find in the source code where was the last good statement that executed. Like this one here, there's some output happened, and then nothing more appeared. If you're out of time, you should go back to your source file and find this place. And in assembly, if it's assembly, it would be comments. Put comments on sufficient number of lines that block out that seg fault. Now, what remains is a running program, but it may not satisfy the entire specification document. But that's okay. It's a way to get more points. Seg faulting, it's 0, so don't even bother that. Comment out the area. It might be a block of stuff where the seg fault is suspected to happen. Comment out enough until it doesn't happen, and then it will run, not performing everything it's supposed to, but it will perform some things. And that's, if that's what you have to submit, that's what you have to submit, and it's okay. And in your group meeting on Friday afternoon, you want to take something with you to demonstrate that actually works, even if it isn't the full set of specifications being satisfied. Your peers, your co-programmers will understand. You only get so much done in a certain amount of time. You can't expect everything. So if you run into that issue of crashing, comment stuff out until it doesn't crash. Here's the worst case. Let's go back to that tree structure, which is the calling structure. This one calls this one. This one calls this one. This one calls here. I think it was manager calls fill the array, and then manager calls display the array, and then manager calls sum the array. If you're seg faulting and you isolate it to some place in the middle of summing the array, that's great. Just put the put the comments inside here. Comment out the bad statements. If you don't know what else to do, go back here and comment out the call to sum. Call sum. And just comment it out and eliminate the seg fault. Let it fill the array and display the array, and don't do this one. It doesn't call it, and it runs to completion and terminates gently. That's a significant piece of work, and I can evaluate what you've done, even if one module is missing completely. It's okay. It's not 100% credit, but it's 89% credit. It's worthwhile. So, now give me a piece of paper. Oh, hold on, everybody. Where's my? Okay. This is pink paper for reading. All right. So just like at the Friday team meeting, non-functioning stuff doesn't count in their eyes. Non-functioning stuff doesn't get you any points. But something that's almost working is like the sum function isn't working. That gets you a lot of points. That's okay. Then when I send you the problem description, the last page, do you remember on the concept test there was the blank question, or I should call it the blank answer? Okay, the last page will be the blank program. Blank program gets you 20%, the same way the blank answer got you 20%. Okay, blank program. What's a blank program? That was the program that said, "Happy birthday, professor." Why? You want to turn in something. You don't want to walk away with nothing. So if you draw a complete, this is a funny way to use the word. If you're drawing a complete blank in your mind and you can't get started on the main program, turn in the blank program. I'll give you something to do for the blank program, and it's just kind of a trivial thing like a one-line message or something. Okay. A lot of people use the blank answer on the concept test, and it saved you a lot, considerable amount of points, and that's all acceptable. Okay, looking at the notes here. Are we catching up? The blank program. I think we're getting caught up. Before we leave today, I want to discuss arrays, static and dynamic. Okay. I'm sorry, I'm looking at my handwritten notes. Are kind of hard to read here. Off to the side, I can't figure it out. Just on the topic of programming. Well, actually, maybe you're already there. You'll end up taking a whole class on proper software design. There's people who specialize in this stuff, and I never was very good at it, but I just know a little bit that works well for me. One is under the one-word title of cohesion. When you make a function, it is a cohesive function if you can express its purpose in one sentence. Back here, summing the numbers in an array, I can express the purposes in the comment area and say, this function computes the sum of numbers in the array passed to it. I can do one sentence. But that's a cohesive function. It just does one thing. But if you have to explain this function prompts the user for how many numbers will be entered, and then enters the numbers, and then sorts them, and then finds the number in the middle, it's too messy. It's not cohesive. So if you need a paragraph to describe what it's doing, it's not a cohesive function. Cohesive functions are good things to have, and you should make that a goal. You don't want it to wash windows and clean the kitchen sink both. You want the function to do a single focused activity. The other one is single entry, single exit. Exit. I assume they teach this on the first semester of all programming. Single exit means you can't have 2 return statements in one function or 5 return statements in one function. Single exit says return happens once. Once. I still get programs to this day submitted with 3 returns in them. C++ programs with 3 returns. Single entry means a single place where you can start execution. In assembly, that's the line directly under segment text. There's your entry place. Can assembly have two entries? Yes, you can. You could have an entry under the word text and another entry right in the middle of the source code, which would be another entry, and you declare both of them global, and you'll have two entries on one function. So the caller function can call entry one or call entry two. It's horribly poor programming to do that, but some people still do. Single entry, single exit is a good thing. It cleans up the logic inside your programming to work that way. Okay. No global variables, no global space. That's really not a problem anymore. Let me see. Modularity. We've been doing this all semester. Modularity means that when we have that tree, it's really not a tree. It really should be called a graph. But we do have one module which is main, and main gets action started, and it calls somebody else. That one can call in turn various other ones, and it calls somebody else, and it calls this one, and main can call over here. We can even have this one at another time come down here and call that one. See, that's not a tree. It's kind of a messy graph. You can have a function that calls itself recursively, and that's not a tree anymore. So when it says it's modular, if this is written in assembly and it's passing parameters down to this one, if it's true modular, we're able to take that file out of the bash compilation sequence, out of the bash file. We remove it and put in a replacement in another language, compile that replacement and link them all together, and it all works without modifying anything else around it. See that? So that's really cool. If you can take this one out and set it aside and replace it with something written in C++, and you can still from C++ call him and him and him, and you can still be called from main, and you've got modularity. That is plug compatible, and that's really a good feature in your software. So that we've been doing it all along by using the integer parameters RDI, RSI, RDX, RCX, R8, R9. If you make your assembly use that sequence in that order to call, let's say it's function A is calling function B, and it's going to pass three integers. And if A uses the first three for the first three integers, and B gets them and it works, you can replace B with the same kind of logic but written in C or C++, and it will be compatible because that sequence is universal among languages that compile. I can't speak for languages that interpret, but languages that compile, that's the sequence that makes this one can be replaced on top of that where that one used to be. Okay, and so that's why we spend all this time on that sequence for the integers, and the other sequences for the float numbers. It's easier to remember because it goes from 0 through 7. It's XMM 0, XMM 1, XMM 7. Yeah. So what if your function has some floats and some integers? is a long and a double and a double and a long and another long, whatever. Okay. So you take, for integers, you take them off this list in sequence. For 64-bit doubles, you take them off of this list in sequence. So automatically this is RDI and this is XMM0. This is XMM1. And I'm running out of space. This is RSI. The next one on the list is RDX. No matter how you mix them up, you just take them in the sequence. For all the doubles, it would be that sequence. And for all the integers, like long, you take them in that sequence. And you'll be plug compatible with any other language that comes along. Let's not do it. You're saying probably what happens to floats? Well, we can do it. I didn't, but it's not worth spending the time on it. If you're passing floats, here's my function, and it's a float and a double, and a float. Okay. You remember the XMM registers? All semester I talked about them as having two halves. This is the low half. This is the high half. And this is 64 bits. And this is 64 bits. Well, to pass a float, you have to split this one in half. And then there's a 32-bit low. So this low 1/4 would be the first float. This would be out of XMM0. And then the next one is a full double. So then that would be the low half here, 64 bits out of XMM1. Yes. And the next one out of XMM2 is just a 32-bit, the low end, XMM2. I'm not going to give any assignments with this, but you should we'll see it one time and then let it go. This is 32-bit, 1/4 of the whole register. And then that accommodates this third parameter, which would be a float. We can pass floats too, but it isn't worth the trouble. There's not much more to learn than what I just told you about. Okay. I think I'm at the end of discussing programming. Does anybody have a question that's related to the Thursday coming? Anything you want to see? Okay. Let's I planned let's not do it this week. I'm going to go over the concept test and solve the harder problems so that you can see their solutions. They occur again on the final exam concepts. So, but not today. Let's focus on programming. I want to finish off with the subject of arrays. Okay. We can categorize arrays in two groups. Static arrays and dynamic arrays. So now, what is the defining property? And let's try and make it clear here. How can I say it? For static arrays, let me do it. We got to establish size. When we say the size of array, it really means not the size of numbers stored in the array. It means the amount of storage that the array needs. So this means storage used by in a specific array. And the storage can be measured as either the number of cells or the number of bytes in the whole array. Okay, so I'm trying to pinpoint down what do we mean by size. Okay, so an array is said to be static if the size can be computed before the program executes. Can be calculated, meaning if the size is known, before execution starts. That means during compiling or during linking. The compiler can look at the source code and count up how many bytes are needed to store this array. Or equivalently, you take the number of cells times the size of each cell, and then you do have the number of bytes. So if the compiler can compute this number, the size number, before it executes anything, that's static array. Okay, so what's the static array look like? It looks like integer my stuff 8. Very static, right? We know what 8 is. That's the number of cells. We know int is 4 bytes. 4 times 8 is 32. Size is 32 bytes. Okay. Static is you can't compute, or yeah, you can't compute. There's one little exception I'm going to add at the end of this. So dynamic means that the compiler or the linker or whoever cannot compute how many bytes are needed for the array until the program actually runs. You cannot know size until program executes. Okay, so they're mutually exclusive. This what's an example of that one? That is well, in C++, it would be integer star my equals new. I missed the word int. int with int. Square brackets 8. Okay, that's an example of dynamic. Now, this is the part I can't fully explain. The 8 is well known. We know what the compiler knows what 8 is. But in the other case, it looks like CIN into I'll make up a name count. And then you declare the array to be my equals new int count. So the second one, it's clearly evident that the compiler doesn't know how many bytes are in that array, but we find out after it executes and the user inputs a number for count. Well, I guess they didn't want to separate these two. They're so similar that they both fall into the dynamic category. For what, for that's just the way it works. They're both considered dynamic arrays. It's the same array, in fact. If the user inputs an 8 number here, you get 8 bytes of 8 times 4 bytes of storage allocated to. All right, that's the dynamic in C++. Okay. Well, the C++ compiler follows the rule that all the static arrays will be stored in the activation record. And all the dynamic arrays in the heap space. Okay. Not all languages do that. In fact, in a moment, we'll see a NASM doesn't do that. Assembly is different. So you can't outright define dynamic by, oh, this array is stored in heap space, therefore it's dynamic. It depends on what language you're talking about. Okay. But in C and for that matter C language, they both follow this rule that when it compiles, enough space is set aside in the activation record to hold the entire array. And when it compiles and is dynamic, no space is set aside until it actually executes this statement up here, like that. Okay. All right, well, and it's not my favorite area, but for those interpreted languages, I just never ought to do a Google search and find out what they do with their arrays. But I've never had interest enough to go investigate that. Okay. So here, let's look at the assembly case. In assembly, we can make an array. Let's do one. My numbers is D. So we go Q. 17, 12, -6, 43. And you just stop. You don't have to have a 0 on the end. That's an array of 4 quad words. And it's their initial values are predefined. So 4 quad words. Each quad word is 8 bytes, so that's total is 32 bytes. It's known when it gets assembled how many bytes are involved, but you know what? It goes into the heap space. This one will be stored in heap. After Thursday's test, we'll come back and use GDB and check where they put these numbers, and GDB will show us that it's in an address that's very, very low numbered. It's less than 1 million. Um, it's not in gigabytes. A size address is a very small address. Okay, we can also create, how about your numbers? And we'll reserve doubles. And we want 100 doubles. So there's an array with no initial data. It has 100 cells. Each cell is a double. That's a confusing word, double. In assembly, the word double means 32 bits or 4 bytes. In C++, the word double means 8 bytes. But we're talking about assembly, and so this is 4 bytes each, and so the total size is 400 bytes. Size equals 400 bytes. Where's that array? It's in the heap. Both of them are in the heap. Even though we know very well what their size is, the translator called NASM has placed them in the heap space area. Okay. Well, I think we're about done with. This was on your midterm on concepts was different than the other classes, other sections midterm. There were different questions, but everybody had a question about dynamic stuff. I think all of them did. But be prepared for the final exam. Dynamic and static arrays will come back. And you should all, C language is such a close cousin to C++. You should all have enough experience that you can put it on your resume and say, not that I'm an expert, but you should be able to say I'm experienced in C language as well. You don't want to disqualify yourself from job opportunities where C is mentioned as one of the attributes they're looking for. So here's how you make an array in C. The static one, there's nothing to it. What's the store? Let's try again. Let's go. So let's make it full of floats. Float. Cost. And you can't tell any difference between the C array and the C++ array. They look identical when it's static. Okay. The C language for dynamic, we have to translate this one, and it's not as clean. This looks nice and pretty, but the C style of doing it is kind of more ugly. Here it is. int star my equals int star, I'm going to run out of space, MALLOC space 10 star. I better go to the next one. Size of int parentheses semicolon. Okay. It's just we don't have a choice to make it look simple. It's just the way it is. So if you're declaring it to have 4-byte ints, you have to say int 3 times. And then this other number is how many cells there are. And this is this number of cells. I think that was on a different, not your section's concept test, is on some other concept test. But now you know. So if you don't want ints and you want doubles or longs, you can make it just as well. Just make the right substitutions. Um, okay, double star yours equals double star now 25 star size of double. 23.6. Okay. You see, you just put any data type that fits in there. Do I have anything else to say about it? No, that's good enough. Okay. Any question? Let me see. I should really get my go to my next slide. That's okay. And then wait, now go ahead. And so for the ASM arrays, they're both static arrays. I'm going no, Greg, they're for ASM, they're both. Oh, let me rephrase that. Yes, they're both static arrays, but they both get stored in heap space. Got that? Let's go back to that page. In assembly, there's a static array. We know everything about it. Your eyes can tell you that these are quad words. There's a quad word, 8 bytes reserved for each one of these. And then we know how many there are. It's what, 8 times 4 is 32 bytes for that. But it goes in that's static, but it goes into the heap. The next one is very similar. We know that these are, the letter D tells us these are 4 bytes in each cell, and there's 100 cells. We know everything about its storage requirements, but yet assembly puts it in the heap. Assembly puts everything in the heap, not in the activation record. In fact, since that question was asked, in your assembly, if you want to build, here you are, you're in segment, not T-E-X-T, and you're working along here, and you suddenly want to make an array dynamically while it's executing. You want to come up with an array. Let's see how we would do it. Okay, now, see, I'm in my head, I'm reading the prototype that's going to be here. 25 times the size of double. The size of double is 8. So that's an integer. That's the first parameter, which is an integer, which is RDI. So here's the block. Set up creation of array. Where are we going to say? Move RAX0. There's no floats involved here. Move RDI. How much 200 bytes, and move, do we need anything else? No. Let's call malloc. Okay, and malloc returns to us a pointer. Here's its type. The type of the pointer is pointer to double. Is that a float or is that an integer? It's an integer. It's a pointer to a double. A pointer already, the word pointer means it's an address. It's going to give us an 8-byte address. And so the return value when it's an integer is RAX. I'll put a comment below here and says RAX is our newly created array. But RAX is very volatile. It's subject to quick changes. The next thing to do is to save it in a safe place. Move R13 RAX. R13 is very safe. It doesn't hardly ever change its value. Now we have two names for the same array. Like I am a person, I have two names. So this array has two names, but the safe one is R13. Comment says R13 is our array of 200 bytes, which if we're going to store doubles there, 8 goes into 200. How many times? 40? I can't do mental math. 2, 16, 25 times. Okay, is our array of 25 quad words. Okay, you can, and this is kind of cool. You can store doubles, IEEE 754 type doubles in a cell, or you can store a long integer 2's complement in a cell. What do you think of that? You can't do that in any other language. Okay, so I better put a number in cell number 3. That's here's an example. Put 392 in cell number 3. Okay, R13 is the name of the array. So here it would go. Move R13 plus 3. That's the cell number. And the size of each cell is a quad word. That's an 8. Okay. Now, everything, you still with me? That's a nice statement, and it makes good sense to humans, but the machine gets confused. The machine says, I can't figure out what the size of this number is over here. Is that stored in a quad word or a double word or a single word? It could be any of them. So you'll get a error message on this, but it has an easy fix. So here it comes. Let's do it the proper way then. Move into the array at that same position, cell number 3. Q word 392. There's a space in between the Q word and the 3, but 392. Okay, so that's called a qualifier. It qualifies the number that follows is to be considered an 8-byte integer, and then it moves those 8 bytes into cell number 3 and occupies all 8 bytes of cell number 3. That's it. Oh, and you were wondering, what can we do a float? Yeah, we can do a float, but there's a problem with the assembler. Suppose we want to put pi into cell number 4. I can't do this. Pi is too complex. Let's even do 2.5. Even when we say Q word, that's not the problem. The problem is it doesn't like this kind of notation for numbers. The assembler doesn't like that. It's not a matter of size like this was. So if you convert that to hex, then it'd work. how do you convert 2.5 without spending a whole day on it? What we do is we say 1 is equal to, what is it equal to? 3FF 0, 0, 0, 0, and all zeros after that. 2 is equal to 4, 0, 0, and all zeros after that. And 4 is equal to, oh, shoot, I can't do that. 401, 0, 0, 0. If I split the difference in the middle, that would be 3.0. Halfway between these two is 400, and then I want a 1 in the first position over here, and that would be an 8. Ah, I see. And you put that right next to a 2 when you split it in half. 2 is up here. We know what it is. Okay. The mysterious 2.5 is halfway in the middle. Can I split this in half? I think so. 400, halfway between is a 4. 0, 0, 0. Okay. So we can't write that because the assembler doesn't read 2.5s nicely. But we could put in its place, we could put 0x 4004 0000 0000 0000, and then it worked. So you can put in the same array some floating point numbers and some integer numbers, and the assembly doesn't care. You have to remember, somehow you have to remember when you read them back out, which ones are the floats and which one are the integers. But assembly will say it's not my problem. You deal with it. Okay, for the okay, I've covered my handwritten notes from this morning. I covered everything that we're supposed to. We could start reviewing the concept test answer key, but you know what? I prefer all of you students. I'd rather you focus on Thursday's test, and when that's passed, then we'll come back to the concept test and go over the questions, especially the hard ones on there. Any questions you got for me? For the files we submit, it will be the S file, the SH file, and the CPU. That's right, Long. That's right. Don't submit object files that end in .o. Don't submit executable files that end in exe or out. Yeah, I just discard them anyway. So just send me those what's called officially source files, and then everything's good. You send them back to my email address, which will be printed in very large bold font near the end of the program description. Anything else you want to know about, everyone? Okay. We still have 20 minutes in this class period, but you're free to go. If I'm just going to hang out here and I'm going to go quiet for a while. Have a nice afternoon, everybody. And remember, we start an hour early next time. Be at your computer 1 hour early. Okay. Yes, I am. Uh, yes, long. Still doing that. 6 o'clock tonight. You can drop in for 3 minutes, and you'll get your hold off.
There's no appointment for that, Professor? Is just drop-in hours?
No, just drop in hours. No appointment needed.
And then it's the Zoom right here.
Same Zoom number. Everybody listening, if you want your hold removed, you can drop in with no appointment today at 6 o'clock with the same Zoom number. There might be 10 of you, and I have to do one at a time for about 3 minutes each person, and you'll get your hold removed.
Sounds good. Thank you.
You're welcome. You're welcome. Lord.